Hi, today we're going to be looking at 2015 PAT paper question 10. So question 10 asks us to find the values of x which satisfy this inequality here. Minus 1 strictly less than 3x plus 4 over x minus 6, which is strictly less than 1. Now, your normal procedure with solving something of this form would be to multiply through by the bottom and solve for x. However, we have no idea about whether this number at the bottom is positive or negative. And if it's a negative number, remember that if you multiply an inequality through by a negative, it in fact switches the inequality. So the way to solve this problem is to not multiply through by x minus 6, but in fact multiply through by x minus 6 all squared. Because we know that squares are always greater than or equal to 0. So let's do that. Let's consider first the left-hand side. So let's consider the part of 3x plus 4 over x minus 6 being greater than minus 1. So as I said, we're going to have to multiply top and bottom by, we have to multiply through both sides by x minus 6 all squared. As this will mean we know it's positive and therefore the sign will not change. So doing that gives us that minus x minus 6 all squared is strictly less than 3x plus 4 multiplied by x minus 6. So let's expand the left-hand side. Minus x squared minus 6x minus 6x minus 12x plus 36 strictly less than, well, 3x squared minus 18x plus 4x gives us minus 14x. Minus 6 times 4 gives us minus 24. So let's bring that all over. So we get 3x squared plus x squared, so that's 4x squared, minus 14x minus 12x gives us minus 26x, minus 24 plus 36 gives us plus 12, strictly greater than 0. Noting here we've brought this over here, so the sign is greater than 0. Okay, so let's divide through by 2 to make this look nicer. X squared minus 13x plus 6 is greater than 0. Sorry, 2x squared. And let's factorise this. So we notice this can be written in the form of 2x minus 1 times by x minus 6 greater than 0. So that's factorising this equation on the left-hand side. So we want to find the values of x for which this equation is greater than 0. So we give a very small sketch here. We have x, and let's call this a function of y. And we know it has a 0 at 6 and a 0 at half. So we just sketch that on. We're going to have it bigger than 0 for the values of, well, this part and this part. So that corresponds to x being greater than 6 or x being less than a half. So that's our left-hand side done. Now we also need to consider the right-hand side of the equation. So let's do that over here. So this time we're considering 3x plus 4 over x minus 6 being less than 1. So again, we multiply through by x minus 6 all squared, so not alter the inequality. So we get 3x plus 4, x minus 6 is less than. Well, let's expand it out straight away because we know what the expansion is already. So x squared minus 12x plus 36, which is just x minus 6 all squared. Expanding the left-hand side gives us 3x squared minus 14x minus 24 is less than x squared minus 12x plus 36. So we bring our x squareds over and the minus 12x over. So it gives us minus 26. Let's write that again. Minus 2x from the minus 14x plus 12x. And we get minus 24 minus 36 gives us minus 60. We want that to be less than 0, strictly less than 0. Dividing through by 2 gives us x squared minus x minus 30 less than 0, which we notice factors into x minus 6, x plus 5 less than 0. So again, we can sketch this. And we see it's going to have a 0 at 6 and a 0 at minus 5. So we're going to get something along these lines. However, this time we require it to be less than 0. So we want this region here. Well, that gives us that we want x to be less than 6 and greater than minus 5. However, we now have to realise that we in fact want both of these things to happen. We need this inequality to hold and this inequality to hold. So this inequality on the left-hand side requires that x is greater than 6. However, the inequality on the right-hand side requires that it is less than 6. So clearly we cannot have x being greater than 6. Now on the right-hand side, we require x to be greater than minus 5. And on the left-hand side, we require x to be less than half. But this inequality on the left-hand side means it can be less than half and go all the way down to minus infinity. So we cannot have that, as we cannot have x being less than minus 5. So we must restrict it between these two values. So we get that our final answer is that x must be less than a half, but greater than minus 5.